Hello students, as in the last lecture we had covered majority of the sums from the second exercise. Okay, so as we had covered the sums based on type number 1, type number 2, type number 3, okay, till type number 6 I guess. Okay, so now in today's lecture we're gonna see the sums based on u into v as well as the sums based on the partial fraction. As I told earlier, we left with 3 4 sums of for your integration part, and then after that we're gonna see the sums based on the properties of definite integral. Okay, so that part we'll see afterwards. Okay, today we'll try to finish out with this integration section, as we hardly left with u into v section and then partial fraction. Okay, so now what exactly we have to do, we all know that the formula for u into v is what? Okay, the formula which we use for u into v in integration, it is different, and here it is different. Okay, it is due to the upper limit and the lower limit. Okay, the formula which we used to apply in integration is used to write u into integration of v minus integration, then box derivative of u into integration of v into dx. Okay, and then into dx. This dx it is for this integration, and this dx it is for this integration symbol. Okay, so now here in definite integral, what is the change? The change is what? Here we have the limit. Whenever we have a limit, the formula will get changed by the derivation part. Okay, so here the formula which you have to use, which you have to apply, it is different. Okay, you have to follow this formula. So that is, it says that u integration v into dx, okay, b to a minus integration a to b derivative of u into integration of v into dx into dx. So this formula you have to apply. Okay, so let's see how to tackle this sum. So as according to the pattern, we know that first come first, we take this word that is light. Okay, L stand for logarithm, I inverse, A algebraical, T trigo, and E exponential. So first come first, as X is algebraical and then sin is trigo, so algebraical trigo, so this will be u and this will be what? V. So simply replace the value of u wherever you see u by x and v by sine. So here you will get what? X integration sine x into dx, then your limit will come pi by 2 to 0, then 0 to pi by 2, yes or no? Now simply you have to replace the value of u and v. Okay, so d upon dx of sine x, sorry, u is what? Here x, u is what? Here x. Okay, don't make mistake. So integral v is what? Sine x into dx, and then this dx is for this integral. Okay, so now, so after this we know that the integration for sine is what? Minus cos, yes or no? So you will write minus cos x pi by 2 to 0, 0 to pi by 2, yes or no? What is the derivative of x? Derivative of x, we know that it is 1, and integration of sine x into dx will be what? Minus cos x, yes or no, into dx. So here we cannot see the integral symbol, so directly we can substitute the value here, upper limit and the lower limit. So first upper limit will come, yes or no? Okay, then minus lower limit will come. Okay, so here we'll write this part as it is, and we know that 1 into minus cos is minus cos into dx. Yes or no? Okay, after this minus minus we can write as what? Plus 0 to pi by 2 cos x into dx. Yes or no? And here you will get what? Pi by 2 into minus cos pi by 2 is what? Cos 90. Yes or no? Okay, so here cos 90 will be what? 0. So here 0 into a number will be what? 0. Yes or no? So now after this we know that here also 0 into a number will be what? 0 minus 0 will be this part, the whole section, this will be what? 0 only. Okay, so plus integral, first we'll find the integration of cos is what? Sin x. Yes or no? Integral of cos into dx is what? Sin x. Then pi by 2 to 0. Okay, so now 0 plus, so first we'll put the upper limit and then minus the lower limit. I hope you all might be knowing how to solve this part. Okay, simply you have to replace the value of x first by upper limit and then by lower limit. So 0, sin 90 is what? 1, and sin 0 is what? 0. So here in the final step we left with what? 1. Okay, so here we got the answer for this sum. Okay, so this was the sum based on u into v. Okay, so remember here the formula, it is different compared to the integration, as it is because of this upper limit and the lower limit. So here we have to use this formula, not this one. Okay, so then only you will get the perfect answer. Okay, so now we'll take one more sum, as here we have x into tan inverse. Okay, so I equals to 0 to 1. Here we have 0 to 1 x into tan inverse x into dx. Okay, so LIAT, according to this word, inverse come first and then algebraical. Okay, yes or no? So here for this part we'll take u and this as v, as with respect to this alphabet. Okay, first come first, we have to consider the first section as u and the second part as v. Okay, yes or no? So here simply you have to replace u by tan inverse and v by x. Yes or no? 1 to 0, then 0 to 1 d upon dx of u. So here u is what? Tan inverse integration x into dx and then dx. Yes or no? Simply you have to replace the value of u wherever you see u by tan inverse and v by x. So after this tan inverse will be same as it is. And what is the integration of x? Okay, yeah, nothing is there, so we can write 1. So use the x raised to n formula. Yes or no? So x raised to n is what? X raised to n plus 1 upon n plus 1. Yes or no? Okay, so here you will get x square upon 2 1 0. Okay, now derivative of tan inverse, we know that it is 1 upon 1 plus x square into, just now only we saw integration of x, that is x square upon 2 into dx. Okay, so now in the next step, your integration section is not there, so directly we can substitute the upper limit and lower limit. Simply replace the value of x by 1. Okay, and then by 0. Okay, here 1 upon 2 we can see that it is constant, so we can bring outside the integral. 0 to 1, so here we left with x square upon 1 plus x square into dx. So the next part, okay, so here 1 square is what? 1. So 1 upon 2 into tan inverse 1 is what? Pi by 4, because we know that tan 45 is 1, so pi by 4 equals to tan inverse of 1 will be what? Pi by 4. Yes or no? and this is 0 square is 0, so 0 into any section, this part will be, whole part will be what, 0 only, yes or no? So here we left with 1 upon 2, 1 to 0, and here we have, clearly we can see that here we have quadratic upon quadratic. Yesterday in the last lecture only, we saw in the last video lecture, whenever you come across the pattern like quadratic upon quadratic, okay, so you have to adjust the numerator in a such a way that the first part it should match with the denominator, and the second part you will get some other term. Okay, so you have to adjust the numerator in a such a way that the first part it should match with the denominator. So here can I say, here we have x square and in the denominator we have x square plus 1. Okay, so can I write here as plus 1 minus 1, and you have to adjust whatever you will do the adjustment, see to it that it should match with the previous step. So here what I did plus 1 minus 1. Okay, so just now only I told you have to adjust the numerator in a such a way that the first part it should match with the denominator, and second part let it be whatever you get. Okay, so this is the pattern, this is the concept whenever you come across quadratic upon quadratic. Okay, and see to it that quadratic upon quadratic, when the middle term is absent, listen, note down, when the middle term is absent, so this is the trick and concept in which you have to find your answer. Okay, okay, so after this, so this we can write as what, pi by 8 minus 0 will be pi by 8 minus 1 by 2, so 0 to 1. Okay, yeah, into dx is there, so we'll separate the denominator, yes or no, we'll separate the denominator. Okay, so this is pi by 8 of 0 to 1, so here this part will be what, 1 minus 1 upon x square plus 1 into dx. As clearly we can see that here we have two term, okay, two terms, so we can subtract the integral. Okay, and 1 upon 2 is constant for both the terms, so we'll write the remaining section inside the box. So here this will be 0 to 1, 1 into dx minus integral 0 to 1, 1 upon x square plus 1 into dx, as 1 upon 2 is constant for both the section, yes or no? So this will be pi by 8 minus 1 by 2. Okay, so integration of 1 is what, x. Okay, and integration of 1 upon x square, we know that it is tan inverse, yes or no? Tan inverse. Okay, now simply what you have to do, first you have to replace the value of x by 1 and then by 0. Here also same, first you will replace the x by 1 and then by 0, and see to it that here minus is there, so your symbol will change, so you will write the section inside the box. Okay, so now here pi by 8 minus 1 by 2, so 1 minus 0 will be what, 1 minus tan inverse 1, minus minus will be plus, so tan inverse 0, here you will get. Okay, so pi by 8 minus 1 by 2, so here what you will get, this part, this one will be same, and just now only we saw tan inverse 1 is what, pi by 4. Okay, and tan inverse 0 is what, 0, yes or no? So in the final step we can write as what, pi by 8. Okay, so bracket open, so here you will get what, minus 1 by 2, this minus minus will be what, plus, this will be what, pi by 8. Okay, and this is will be 0. So here pi by 8 and pi by 8 will be what, 2 pi by 8, so here you will get pi by 4, yes or no? Minus 1 by 2, because we know that pi by 8 plus pi by 8, So this can be written as denominator is same, so pi plus pi, it is 2 pi, 2 ones are 2 fours are, so this pi by 8 plus pi by 8 we can write as pi by 4, and here we left with minus 1 by 2. So here we got the answer for this integral x into tan inverse. I hope you all understood this sum, and the same sum actually we had did in the integration chapter also. We took the same example x into tan inverse while dealing with the u into v integration. We took the same example there also. I had explained the same thing. Okay, so just the change is what the sum, it is based on the definite integral. So here we have to put upper limit and lower limit to find our required answer, and see that here the formula, it is little different. So you are here, you have to follow this formula, not this one. Okay, so I guess you all understood the sums based on u into v. Okay, using this property, not this one. This is for the integration chapter, and this is for the definite integral. Okay, so don't be confused in this two formula. Okay, as here we have the upper limit and lower limit, because of this the formula is changed here. Okay, so I hope you all understood this one also. So let's move on to the next sum, and next few sums is based on what, the partial fraction. As partial fraction, I guess it is the last type, last exercise of your integration. So hardly we left with the last section of your integration topic. Okay, so when you will see the exercise number 2, so I had covered almost all the sums with respect to the all the types. Okay, so now we left with only with the one sum which is based on the partial fraction. Okay, so we'll try to cover that also, and then after that we can say that almost we had covered all the types based on the integration, and we hardly left with the properties of the definite integral sums. Okay, so that we'll see in the next next lecture. Okay, so now we'll move on to the next section, that how to find the answer for the partial fraction. So here we have the sum, that is 2 to 3, 1 upon x plus 2, x plus 3, and we know that how to tackle this sum. As whenever we come across the pattern like px plus q upon x plus a and x plus b, yes or no? This is what a type number one we can say of the last type sub question, when the denominator section, okay, this is what a linear factor is non-repeated. So whenever the linear factor is non-repeated, so we know that exactly what we have to do. So we have to write a upon x plus a, and then b upon x minus b. Okay, so this is the pattern which we have to follow for the partial factor, because we know that the given question, the given format, actually it is in the form of u by v and here in the integration we don't have the formula for u by v. So now we have to adjust the things, the integral, this section in a such a way that further we can easily integrate the part. So this clearly we can see that this look like what partial frac partial fraction. Okay, so let it be in the numerator if it contain linear, quadratic, or a number. Okay, it doesn't matter, quadratic, linear, or a number. And here we, when in the denominator when you see a non-repeated linear factor, so this is the format which you have to follow. Okay, simply what you have to do, okay, first you will write a upon x plus a and then b upon x plus b. Okay, then after that you will put x plus a equals to 0, so where you will get one value of x. Then you will put x plus b equals to 0, so where you will get the second value of b x, sorry. So simply you will replace the value of x wherever you see x by minus a, so where you will get one answer. And then after that substitute the value of x by minus b, where you will get the second answer. So with the help of this two value of linear factor, you will get the two answer of this constant. Okay, so here we have to find a and b. So a and b, with the help of this value you can find your answer. I hope you all might be knowing this section. Each and everything I had explained in detail in the integration chapter when we were dealing the sums based on the partial fraction. So in the partial fraction also there are three subtypes, in which this is what a first type. Okay, so now we'll see exactly what you have to do. So here we know that first we'll take let. Okay, so here see that here we are taking let. Okay, but here while taking let we are not derivating with respect to x, just simply we are taking let just to break this format in this part. Yes or no? So see that whenever you take let and you derivate with respect to x, that time only the limit will get changed. Otherwise the limit will be same as it is. As in the last video lecture I had explained, whenever you deal the sum with respect to let, you have to change the limit. Okay, when you are applying the derivative, because in integration we know that whenever we take let, so of course we derivate that part with respect to x. Okay, and then after that only you have to change the limit. As for this sum, we'll be considering only let, but we will not be derivating this part. Yes or no? I hope you all might be knowing whenever a partial fraction we convert in a upon x plus a plus b upon x plus b. Okay, just simply we find the value of a and b. Okay, we are not derivating this part with respect to x. So if you are not derivating the part with respect to x, so the limit will be same as it is. Keep this point you in your mind. Okay, let derivate with respect to x, then only the limit will change. Okay, so now here let. Okay, so here 1 upon x plus 2 x plus 3 can be written as a upon x plus 2 plus b upon x plus 3. Okay, if you want you can solve this sum by using this method also. Just simply bracket open this section. So when you will bracket open this x plus 2 and x plus 3, here you will get x square plus 5x plus 6 into dx. So this actually get converted into what? 1 upon quadratic form. Yes or no? So 1 upon quadratic means what? Type number 1a. So we know that how to solve the type number 1a section. Okay, and see to that whenever in the numerator 1 it is there, then only we can solve this sum by using the type number 1a. Suppose here we have x or any other term, so we cannot able to apply this format. Okay, so for this sum, actually only for this sum, as here we have 1, so we can bracket open this part. So here you will get quadratic. As clearly we can see that this look like 1 upon quadratic, and 1 upon quadratic means it is a type number 1. Okay, but I will show this sum by using partial fraction. So let it be, if here we have number or a linear expression or a quadratic, the format will be same. Okay, so now after this we know that just to make this part straight, so simply we'll multiply throughout by what? X plus 2 and x plus 3. So here you will get what? 1. Here x plus 2 will get cancelled, so here you will get x plus 3. Here x plus 3 will get cancelled and you will left with x plus 2 here. Yes or no? So now first step, you will put x plus 3 equals to 0. So x will be equals to minus 3, and x plus 2 equal to 0. So x will be equals to minus 2. So simply what you will do, you will replace this x by, in the first case you will replace the x by minus 3, minus 3. So this will be what? 1 equals to minus 3 plus 3, it is 0. So 0 into a number will be 0, and here minus 3 plus 2, it is minus 1. So therefore 1 equals to 0 minus b. Okay, so therefore 1 equals to minus b, so that is we can say b value is what? Minus 1. So now we'll consider the second value. So second value is what? X equals to minus 2. So simply you will replace the value of x wherever you see by minus 2, yes or no. So minus 2 plus 2. So therefore 1 equals 2. So here you will get what? Minus 2 plus 3, 1. Here this will get cancelled, so 0. So therefore here the value of a you will get what? 1. So here we got a and b value. And see to it that just now only I had explained. Okay, whenever you take let in integration, basically we do derivative with respect to x, then only the limit will change. For this sum, just simply we are expressing this function in this format. Can you see anywhere in any step I did derivative with respect to x? No. So therefore the limit will not change, it will be same. Okay, clear? Now after this, 1 upon x plus 2 x plus 3 is equal to a. So here a is what? 1 upon x plus 2. B is what? Minus 1. So this plus minus will be minus 1 upon x plus 3. Okay, so now we know that I is equals to 2 to 3 1 upon x plus 2 x plus 3 into dx. Just now only we saw we add express this function as in this form. So 2 to 3 1 upon x plus 2 minus 1 upon x plus 3 we can write, yes or no? Okay, so now here we had converted this u into v pattern in a such a way that now easily we can integrate this function. Just simply separate this integral, so you will get 1 upon x plus 2 into dx minus integral 2 to 3 1 upon x plus 3 into dx. As clearly we can see that this look like 1 upon x integral, which is equals to what? Log mod of x plus c. So here you will get log mod x plus 2, yes or no? 3 2, as we know that 1 upon ax plus b is what? Log mod ax plus b upon a plus c. As here a is what? 1, so no need of writing 1 upon 1. Okay, then minus, here also same, log mod x plus 3, as both the section look like 1 upon x, yes or no? So now simply you will replace first by upper limit, so 3 plus 2 will be 5. Then by lower limit 2 plus 2 is what? 4. Okay, first we'll replace it by 3, so 3 plus 3 is 9, and by 2 2 plus 3 is what? 5. So here we got log 5 minus log 4. So can I write this log 5 upon log 4 as log 5 by 4 using the formula log a minus log b, which is log a by b, yes or no? Here also same formula will use, so minus log 9 by 5. Okay, so again further this look like log a minus log b, so which we can write as log a by b, yes or no? So further this can be written as what? Log 5 by 4 into reciprocal, so 5 upon 9. So final step, so actually here I did a mistake. 3 plus 3, actually it is not 9, it is 6. Okay, sorry, I did the multiplication between these two, because 3 plus 3 is what? 6. So this will be what? 6. Okay, so don't do such kinds of mistake in the exam. Okay, so here 3 plus 3 is what? 6, not 9. I did multiplication here. Okay, so sorry from my side. So here 5 5 side is 25, so log 25 upon 4 6 are 24. So here we got 25 upon 24. In this sum also, when you will apply third term formula, in this sum also you will get the same answer. But see to it that whenever this numerator section is replaced by some other term, like by a linear or a quadratic, so we cannot use this format. Okay, this format we can apply only when in the numerator 1 is there. So I guess you all understood the sum based on all the types of the integration. as this was the last type based on the partial fraction. There is one more sum in front of you all, so please try this sum by yourself. Take this sum as homework. Okay, so almost we had connected with all the sums, all the type. Okay, so as I told, the 70 to 80% of the sum it is based on the integration, so I tried my level best to cover all the types. Okay, and we left with the last part of your definite integral, that is based on the properties of definite integral. As I told, there are 7 to 8 properties. Okay, in that also there are selected 3 4 properties which are very important, and in the exercise will when you will see, when you will come across, based on that 3 4 selected formulas only the sums are there. Okay, not based on all the properties. Okay, so as here clearly we can see that the property number 4, it is very important as there are lots of sums. Okay, and even property number 5, sorry, this is what 5, so this will be what 6, and this will be what 7. So out of 7 8 properties, the first 3 is normal one, fourth, fifth, sixth and seventh, that is very very important, as clearly we can see that there are here in that also, in that only I had given some example. Okay, so for each and every property we'll take two example and we'll try to cover this part also. Okay, so we left with the last part of the definite integral, that is sum based on the definite integral properties. Okay, so in the next lecture we're gonna do these sums and we'll try to finish all the sums based on this properties. Okay, and in the next lecture we'll try to complete this chapter. Okay, so till then, goodbye, see you in next lecture.